All right, so now we're moving on to the last video of this unit, and that video is going to be 3D. And what we're focusing on now is graphing linear inequalities that now have two variables. So before we were focusing on linear inequalities, it just had one variable, x is less than 5, or maybe x is greater than or equal to 3, but we only had one variable. Now we're going to be focusing with two of them. All right, so what you'll need to know by the end of this video is you'll have to know if a given coordinate is a solution to a linear inequality with two variables. So now instead of doing it like this of x is less than 5, we're now going to be saying maybe y is less than or equal to negative x plus 2. So you'll have to know, if I give you the points negative 5, 3, you'll have to know, does this satisfy, is it a solution? And then not only will you have to know that, you'll also have to be able to find all of the solutions. So you'll have to know how to solve a linear inequality with two variables by graphing. All right, and that's how we then determine all of the points that do satisfy this inequality. Rather than just checking for one, is we graph it. All right, so we're first going to start off with the video by talking about how you can determine if a given point is a solution, and that's important because we'll need that as we go to do our graphing part. And then we'll move into graphing inequalities with two variables. All right, so the first part of this video is just checking to see if a given coordinate is a solution to a linear inequality. So if we're asked to determine or tell whether the ordered pair is a solution, what we need to do is substitute in and see, does it give us a true or a false statement? Does it satisfy it or does it not? So in this case, we know our ordered pair is written as xy, so I can say x is equal to 2 and y is equal to negative 2. And now I'm going to plug them in. So does 2 minus 3 times my y, which is negative 2, is that greater than or equal to 8? So you see I'm putting a question mark above it because I don't know, so I'm going to test it. All right, so now we have 2. Well, negative 3 times negative 2 is a positive 6. So is this greater than or equal to 8? Well, 8 is greater than or equal to 8, so this does work. If it didn't have that equal sign, then we wouldn't be able to say it does. So yes, this does satisfy our inequality, and it is a solution. So to determine if something's a solution or not, you simply just need to substitute it in, work out all the math, and see, does it give me a true or a false statement? Does it satisfy it or does it not? And if it does satisfy it, it is a solution. All right, let's go ahead. We're just going to do one more like this. All right, so now for the second example, same thing. We're given an inequality of y is less than negative 2x minus 3, and we're just asked, is negative 1 and 9 a solution to this? So what we need to do then is say, well, x is equal to negative 1 and y is equal to 9. Then we're going to substitute it in. So is 9 less than negative 2 times negative 1 minus 3? Well, negative 2 times negative 1 is 2. So is 9 less than 2 minus 3? Well, 2 minus 3 is negative 1. And 9 is not less than negative 1. So this is not a true statement. It's false, so it doesn't satisfy it. So no, it is not a solution. All right, so this is something that's really important, though, that you need to be able to do when we actually go to graph. All right, so no, it is not a solution. So we need to be able to substitute in and identify if it works, then it is a solution. If it does not work, it is not a solution. All right, so before we actually move on to graphing anything, I do just want to talk about a couple things that we are going to ultimately have to be able to do when we're graphing. All right, just like when we are graphing with one inequality, when we saw that there was less than or greater than or less than or equal to or greater than or equal to, we had to represent those differently so that way the reader knew if we were including that number or not including it. And we know that when it was just less than or greater than, it was an open circle or a not solid circle, and when it was equal to, we had to have that solid circle. And this will let the reader know that we were including 8 or we weren't including 5. Well, we will also have less than, and we'll also have less than or equal to or greater than or equal to or just greater than when we're dealing with inequalities with two variables. So we also have to be able to represent to the reader if we're including the numbers that fall on this line or if we don't include the numbers that fall on this line. And the way that we represent this is when it's just less than or if it's greater than as well. So I'm going to put greater than here next to it. So when it's not equal to, it will be a dotted line. So when we actually draw our line to graph, we will draw our line as a dotted line, not a solid line. Same kind of thing here. The less than or greater than was not solid. So it's the same thought process. It's not solid, so we're not including those numbers. Where if we have an equal to, so in this case greater than or equal to or less than or equal to, when we draw this graph, it will be a solid line to represent that we can use any point that falls on this line. So any point that fell in this line for the green graph would be equal. And since it will be equal, we can't include it as a solution. So it will not work. So we need to represent that through a dotted line. If it's equal to, it will satisfy our inequality. So then that means that we need to represent that, and we do it through a solid line. And one of the things I just want to bring to your attention is when we do this, let's just say this is what our graph looks like. Our graph actually cuts our coordinate plane into two different regions. And one of those regions, all of the points, all of the coordinate plane or coordinate points in that plane will work and satisfy. And we're going to learn about that in just 1 minute when we actually go through our next example. But the one thing I need to point out to you that you needed to make sure you knew is that if it's just greater than or less than, we have a dotted line. And if it is greater than and equal to or less than or equal to, it is a solid line. All right, that's what you have to do when you're graphing these, just like we did with one variable. All right, so if you knew how to graph an equation, this is really easy. All right, that's why I was trying to really hammer in that you needed to make sure you practice, needed to make sure you got this down, because as we moved into inequalities, it may seem really difficult, but it's really not much more than what we were doing before. So if we're graphing this is in slope-intercept form already. So we need to find what our slope is, and we need to find what our y-intercept is. Well, our slope is -2 in this example. Let me change the color for my y-intercept. My y-intercept is 3. So remember, this gives us a point of 0, 3. Whoops. This gives us a point of 0, 3 as where we cross our y-axis. That's why it's our y-intercept. So I'm going to put this point here at 0, 3. Remember, our slope is our change in y over change in x. So this -2 is -2/1. So it means that we're changing in our y going down 2 as we're moving over 1 to the right for our x. So we're now going to draw that. 1, 2, going over 1. 1, 2, going over 1. All right, now we plot those points. Normally, we just take out a ruler without thinking, and we just draw our graph. Well, now when it's an inequality, we need to ask ourselves, is this a solid line or is it a dotted line? And since it is just less than and not equal to, it is going to be a dotted line. So now I can't draw using a straight edge on this, this document, so you're going to have to make sure you use a straight edge when you're doing this on your work. But I'm going to do my best to make this a straight edge. Actually, let me pause this. All right, so you will use a straight edge still, but make sure you don't just draw that straight line because it needs to be dotted. All right, so this is what our graph will look like, and yours will be much better and straighter because you'll be able to use a straight edge easier than I can here. Now, when we graph this, it breaks our graph up into two different regions. You see we have this region up here, and we have this region down here. Well, we need to shade a region, and that will tell us all of our answers. So what we do is we pick a point. All right, pick a point in a region. If 0, 0 does not fall on your line, I suggest you always pick that point because it's the easiest to work with, right? But do not pick a point that falls on the line. Pick a point that falls in a region. So I'm going to pick this point here of 0, 0. Right? That's the point I'm picking. And I'm going to test it. Does it work? All right, y is less than -2x plus 3. I'm testing the points of 0, 0. So we substitute 0 in for x and 0 in for y. Well, is 0 less than -2 times 0 plus 3? Well, 0 times -2 is 0. So is 0 less than, sorry, we don't need to write that anymore. Is 0 less than 3? Yes, it is. So that means that this point works. In this region, every single point will work then. So my answer is coloring in this entire region. Right? By doing that, I'm letting the reader know this region, every single point in this region works as a solution. So if one of them works, all of them will work, right? And make sure you're always plugging it back into the original problem. If you needed to manipulate this in any way, make sure you're plugging it back into the original and not to any work you did, because then you'd be able to find your mistake possibly from there, right? And then since this region did work, that means the one above it will not, and we don't even need to test it. If you wanted to test it to see maybe so you didn't make a mistake somewhere, then you can go ahead and check that region as well, and it should or would give you a false statement and doesn't work. And if it did, then that means that your graph is completely wrong and you need to rework out your graph. All right, so that is our answer. That's it. So we're essentially just graphing like we did as an equation, but now we have to say, okay, is a line solid or dotted? And then we need to actually pick a point on one of the regions and test it and see, okay, which region am I coloring in? All right, let's go ahead and do another problem. All right, so then the next example and the last one we're going to go through is this one here as well. So when it's given to you in this form, If you know how to graph in standard form, you can go ahead and graph that way. And remember, to graph in standard form, you will just find your x and y intercepts. It seems like most of the people like to rewrite this into slope-intercept form. So I'm going to only do that on this video, but maybe I'll make another video going over how you can do it using the standard form, or we can go over it in class. But we need to pay attention to if we're dividing by a negative number, just like we would if we were solving a regular one variable inequality. So if we wanted to rewrite this into slope-intercept form, first thing I'll do is subtract 2x on both sides. So that way I start to isolate my variable y. So now I have negative 3y is less than or equal to negative 2x plus 15. Right? Then from there, we would then have to divide each side by that negative 3. And since we're dividing each side by a negative number, we still have to have that rule that the inequality needs to flip. So that's why I do think if you know how to graph in standard form, it might just be easier if you can, because then you won't forget to flip that inequality. But if you want to do it in slope-intercept form, if you are dividing both sides by negative like we are here, remember to flip that inequality. And remember, this then creates two separate fractions. Negative 2 over negative 3 gives me a positive 2/3 x, and 15 divided by negative 3 gives me minus 5. So now I can go ahead and say that my slope is equal to 2/3, and that my b is equal to negative 5, and that is the point of 0, negative 5. So I'm going to go ahead and plot that point of 0, negative 5 first. My slope is change in y over change in x. So my change in y is positive 2, so I'm moving up 2, 1, 2, and then I'm moving to the right 3, so 1, 2, 3. So there's my next point, up 2, so up 1, up 2, over 3, so 1, 2, 3. There's my next point. All right, now when I go to graph these, I need to ask myself before I draw this, is this going to be a solid or is it going to be a dotted line? And since it is equal to, I know it is going to be a solid line. So you will take your straight edge and you will draw your graph. Now, when you are drawing these graphs, I do ask that you extend it all the way to the end of your coordinate plane. So that this way it does clearly cut our graph into two separate regions. All right, make sure you're still putting your arrows just like you would for the regular graph as well. And now we need to test a point, test a region. Now remember, we never test a point that's on the line. Since 0, 0 does not fall on this line, I'm going to test it. So now I'm going to say, does 0, 0 work? Plug it back into the original. Do not plug it back into this one here, because if you made a mistake, you might mistakenly write or put the wrong graph, a region or whatever it may be. So pick the one and put it back into the original. And then we just test it. Does 2 times 0 minus 3 times 0, is this less than or equal to 15? Well, 2 times 0 is 0, 3 times 0 is 0. So 0 is less than or equal to 15, and correct, that region must work. So that means all of the points in this region work, and we can go ahead and color and shade that region, and that will be our answer. All right, so that is it for this video, and there is a little sheet I'm going to hand out with you in next class just to give you like a little bit of a note to have. But that is it for this video.